with these questions, remember that we were working on our very last formula. That's this one, VF squared equals VI squared plus 2AD. Okay, and I think we actually went through like 1A together before the bell rang. Okay, and we found out that you actually didn't need that formula to get the jet's acceleration, but you did need that formula to do part B. All right, then I would like you guys to work on question number 2 after that. So I'll give you a few minutes to kind of find that. Try question 1B, we'll go over it and then give you some time on number 2 there, okay, to try that one again, same formula, right, and we can have a look at those here in a minute. Okay, so for question 1B, okay, we calculated in 1A the acceleration using VF minus VI over T. Okay, and we got that it was 2.4 meters per second squared backwards. Okay, they have negative forwards, which is the dumbest thing you can possibly write. That's like saying, as long as I'm negative right, I'm wrong. Okay, we don't write a negative, it's just dumb. Okay, negative forwards is backwards, just write backwards. Okay, that'll be fine. Now for part B here, okay, we're looking for the length of the runway, so we're looking for D. Okay, we know that it runs on the landway, lands on the runway at 70 meters per second, comes to a halt, so we know VF is 0, and we just calculated A, so now we can find D, but we have to manipulate to get D by itself. So I'm going to subtract VI squared over to the other side. That equals 2AD. Then I'm just going to divide by 2A, and that'll leave D by itself. So I'll have 0 squared minus 70 squared divided by 2 times negative 2.4. All right, it's important that I have the negative on the bottom and the 0 minus on the top. So I'm dividing a negative by a negative, okay, on that one so that I get a positive direction for my travel. Okay. So 0 minus 70 squared, and will give me that, divided by negative 4.8. Okay. Must have done that wrong. Yeah. Double check my acceleration from the first part here. Okay, if I carry all the decimals through, then it works. That's not right, but okay, it comes out to 1 kilometer here to 2 significant figures, 1.0 times 10 to the 3. I must have typed something in wrong before. Okay, all right. How many people have done number 2? All right, I'm going to give you a couple more minutes on number 2, and then we'll have a look at that one. All right, so on number 2, we're talking about on-ramps and how they're supposed to be designed, okay? So modern freeways, like let's say Stony Trail, all use proper interchanges to have traffic merge onto and off of the highway, okay? If those are designed correctly and don't have stoplights at the top, like most interchanges in Calgary do, which is dumb, but okay, if they're designed properly, then they will allow you to, have your acceleration and get up to speed before you reach the main part of the traffic, which eliminates accidents, makes everybody safer. Okay, so we have these on-ramps that are designed to have them move seamlessly in. The car needs to increase its speed from 50 to 100 kilometers per hour. Now I need those in meters per second first off. Okay, so the first thing I need to do is figure out what those are going to be in meters per second. So 100 divided by 3.6 should give me 27.7, okay? Repeating, okay, and then obviously 50, okay, will be half of that. All right, so we're looking at 13.88 repeating, meters per second and meters per second. All right, so those are our 2 speeds, and an engine's acceleration an engine can provide an acceleration of 3.8 meters per second squared. So we have that. Now we're going to assume obviously that all of this is in the same direction because it has to be, okay, in order for us to do this. So we're looking for D. So we got VF squared equals VI squared plus 2AD, same manipulation as the first one. All right, VF squared minus VI squared equals 2AD, so we divide by 2A, and that will give us our displacement or the minimum length of the ramp. Okay, so when we plug in our numbers here, that's going to be 27.7 squared minus 13.8 squared, okay, divided by 2 times 3.8. So okay, and I did this, guys, just so that I would get all those decimals again. So I'm preserving my significant figures here. All right, so we're getting that this comes out to 76 meters to 2 significant figures. Right, so the length of the ramp has to be 76 meters to allow a car to go from 50 to 100, okay, while accelerating down the ramp. Okay? And this is exactly the kind of calculation that, you know, a city planner would have to do when they're designing an interchange. Okay, they need to figure out how long do these ramps need to be so that people can safely reach, you know, the merging speed or the speed of traffic. Okay, things like that. So they're all like practical and useful types of things. Okay, questions on any of that? All right. Those ones are going to skip for now. Okay, I want you to try this one. Okay, write it down and see if you can figure it out. See which formula you're going to need. Okay, sometimes a question seems like it doesn't give us all the information, but sometimes we have to get it from the context of the question. So if a bolt falls off of a roof, what was its initial velocity? Zero. You didn't throw it. Okay, the only way it could have a velocity other than zero initially is if you threw it. So we know that VI is zero. That's something we have to get from the context of the question. Because it's falling, what's its acceleration? 9.81 meters per second squared. Again, something we have to get from the context of the question, right? And we are looking for how long it will fall for. So we're looking for a time here, okay? And it is 6 meters above the ground. Okay, which formula am I looking at here? I have VI, A, D, and T. Well, I'm looking for T. Exactly, it's this one. You know, that one I told you you'd never have to use to solve for T, except when VI is zero. Since VI is zero, I only have to worry about that part of the formula because VI times T is going to be zero. So now I'm solving for T. I'll divide both sides by 1/2 of A and square root. Okay, so we'll have 6.0 divided by 1/2 times 9.81. Notice I'm not making either one of those negative. They're both downwards. There's no sense. I either have to make them both negative or I have to make them both positive. Either way, okay? Just makes a little more sense to do it that way. All right, so we're going to have the square root of 6 divided by 0.5 times 9.81. Okay, and you do have to bracket that bottom part or it won't come out right. So it's going to fall for 1.1 seconds. Okay, it'll take 1.1 seconds for it to fall 6 meters off of the roof. Okay, questions on how that one worked? Okay, so again, guys, lots of times you're going to get a problem like this that doesn't seem like it gives you a lot of information. You have to read into it a little bit more than normal. Okay, let's try this one here. See how you do on this one. I'll give you a couple minutes. All right, so as always, guys, we want to write down our givens first. Okay, we're looking for the final velocity. So we're looking for VF. You have a rock that's propelled over a 0.30 meter distance. Okay, by an acceleration of 22 meters per second squared. Okay, for 0.72 seconds. All right, I'm looking for VF. I have D, A, and T. Which formula should I be using here most likely? Exactly. D equals VF times T minus 1/2 AT squared. All right, first thing I want to do if I'm solving for VF is I want to move 1/2 AT squared over to this side by adding it. So D plus 1/2 AT squared is going to equal VF times T. Then I'll just divide both sides by T, and I've got VF by itself here. Right, and so now I just plug in my numbers. So that'll be 0.30 meters times 0.5 times 22 times 0.72 squared, okay, divided by 0.72. Sorry, that's not supposed to be times, that's supposed to be plus right there. All right, so we're looking at that it will have a final velocity of 8.3 meters per second. Our final speed, I guess, in this case, because we were never given any directions, 8.3 meters per second. Okay, are we seeing how this kind of works? All right, it's always going to be the same set of steps. I got to figure out which formula I need to use based on the givens the question gave me, and then I just solve, okay, manipulate and solve from there. All right. Now let's try that one. Okay, we're looking for the initial velocity of a bullet that enters ballistics gel. That's that stuff they use on Mythbusters sometimes when they shoot stuff at it because it has the same consistency as the human body. Okay, slows at 150 meters per second squared for 0.252 seconds. Its final velocity is 65.2, which means it didn't stop. That's a through and through. Yeah, bullet didn't stay inside. It went all the way through. Okay, not good. Right. Okay, so on this one, we're looking for VI. Okay, so that's our question mark. Okay, it enters the ballistics gel, and we have the acceleration. So the acceleration is negative 150 meters per second squared. Crucial that we have that negative on there. It is, after all, slowing down. Okay, we know that it's interacting with the ballistics gel for 0.252 seconds. Okay, and its final velocity is 65.2 meters per second. All right, so which formula am I going to use for that one? Okay, Skylar, which formula would I use for that one? Change in velocity over change in time. So that's the one from Science 10. VF minus VI over T. I'm manipulating for VI, so I'm going to multiply both sides by T. I'm going to add VI over here, and then I'm going to subtract T times A over here. So I'll have initial velocity equals the final velocity minus the change. Okay, so that'll be 65.2 minus 0.252 times negative 150 meters per second. And that negative there is crucial because that means I'm actually going to end up adding it together, okay, giving me a larger number for VI, which makes more sense. Okay, so 65.2 minus 0.252 times negative 150. Right, giving us an initial velocity of 103 meters per second. Wasn't moving very fast. Okay, it's not a very fast bullet, not like the one we talked about on Friday. Okay, that was moving at almost 3 times the speed of sound. Okay, any of you have nightmares about that after that one? Okay. All right, questions on number 3. All right, so we're looking for distance here, okay? Trying to figure out how far a plane flies if it's accelerating at positive 4.52 meters per second, and it's going from 123 to 300 meters per second. All right, so for this one here, guys, we're looking for how far the plane flies, so we're looking for D. Okay, we know the acceleration, positive 4.52 meters per second squared. Okay, we've got VI. So 123 meters per second, and we have VF 300 meters per second. All right, so this is obviously then this formula here. All right, and we're looking for D. We have VI, we have VF, we have A. All right, so D will again be VF squared minus VI squared over 2A. We use this formula so often in that form. Right, when we're doing projectile motion, we're looking for maximum height of an object, things like that. Okay, this formula comes up all the time. All right, so when we do this one here, we're going to have 300 squared minus 123 squared divided by 2 times 4.52. All right, when we do that, we should get that it's going to travel 8.28 times 10 to the 3 meters, okay, or 8.28 kilometers, right, in order to do that acceleration. Okay. All right, how are we feeling about these acceleration problems? Okay, so plan for today was not to spend obviously the whole class working on acceleration problems, but we're going to spend a fair portion of it because tomorrow, okay, we're going to be doing the acceleration lab, right, where we're going to run some carts down a ramp here, record their acceleration, so we'll have to be able to do some velocity versus time graph stuff, some calculating acceleration stuff, okay, and have a good understanding of how that all works, okay, for tomorrow. So what I want you working on right now, okay, so if you go into your workbook here for Unit 1, so the kinematics worksheet book, I think we're going to be on page 5-ish, somewhere in there. Okay, so yeah, very bottom of page 5 is where question number 1 starts. We'll actually skip question number 1 for now. Let's have you start on question 2. Okay, just kind of read those carefully, give them a try. Obviously, you can call it up on your phone as well. The answers are here in bold after the question. All right, so you'll know if you did it right or not. Okay, I'll blow it up a little bit bigger, so it's a little easier to see. Okay, and then I'll circulate, guys, here and there, and if you have problems, just let me know, and I can give you a hand. All right, so for number 5, we have a change in direction most likely going on here. Okay, a car is coasting backwards down a hill at -3 meters per second. So VI is going to be 3.0 meters per second downhill. Okay, the driver gets the engine started, and after 2.5 seconds, the car is moving up the hill at 4.5 meters per second. Okay, what's the average acceleration of the car? All right, so we're basically just using this formula from Science 10, and we don't have to manipulate it. The key here is getting the positives and negatives right. Okay, so for VF, we're moving up the hill, so that'll be positive 4.5. We're going to subtract negative 3.0 because initially it was moving down the hill. We're changing the velocity here by 7.5 meters per second, because it was initially moving backwards and at the end is moving forwards, right? And we're going to divide that by the time, which was 2.5 seconds, okay, which is how we get 3, because we got 7.5 on the top divided by 2.5. That's 3.0 meters per second squared, sorry. And that's positive because in order to go up the hill after having been moving down, our acceleration would have to be up the hill. Does that make sense? Okay, like if we plug that into our calculator, okay, we're going to have 4.5 minus -3, okay, and then we have to divide that by 2.5. Okay, so we get 3. All right. And the other one's giving us trouble we need to go over. Don't be afraid to ask, guys. Okay, and keep working. I'll put that back up here. Oh, sorry. Who is it? Yeah.
I just have a question about adjusting the feature.
Mm-hmm.
For example, with number 6.
Mm-hmm.
If we were to, if that were a question on test, we put 30 to 40 seconds rather than 29 to 40 seconds. We get it.
Well, yeah. No, you wouldn't. I'm just saying that curve started just before the 30. That's why I said 20. If you said 30, I would say that's totally within reason of you reading that graph properly. Yeah. Okay. Any other ones there, guys? All right, keep it going then.